Hello and a very warm welcome to this video. My name is Sven Ingelfinger and today we want to talk about a quick and dirty entry to the Altium Designer world. I will show you how you can create a first project and a little schematic library, and we will dive right into it right now. You see on my screen the Altium Designer 21. I will open a first project for you. I will create one under File, New, Project. Then a submenu pops up and you can decide if it's a PCB, a single PCB project, or it's a multi-board PCB project. And you can set the destination where it is located, a local project on your PCB or maybe on your Altium 365 cloud. I will call this one demo and store it under my desktop. Oh, there's another one existing. Here you can add parameters, but you can also add them later during the design process to your project. So let's create it. So first we have to do is we have to add a schematic sheet, and we have to add PCB document. So the schematic sheet is the place where all the theoretical stuff happens, and the PCB document is the opposite, where all the physical stuff happens. For example, your component placement, your routing and all that stuff. So start with the schematic sheet. It comes a simple sheet. It comes up with a simple sheet. The default settings are based on template, which comes with your installation of the Altium Designer, and you could easily edit this sheet templates and also use your first components. The panels I have open right now is the projects panel on the left side and the properties panel on the right. You can easily open other panels with the section on the right bottom corner, the panels button, where you can see projects and properties is open right now. I could also easily add Explorer components panel or something like that. Yeah, let's start with the components panel. Move on to the components panel. The components panel is the central base from where you can add all your components from different libraries. As you can see in the top drop-down menu, there are two integrated libraries available right now. They also come with the default installation of the tool. We have miscellaneous device and we have miscellaneous connectors. All those components are available with the installation, so you can use them directly. You can drag and drop them if you want, but you could also make a right click on it and say place diet, for example. Okay, that's also a way where you can integrate other libraries which you have downloaded, maybe from GitHub, maybe from manufacturers, from a colleague, or from your last company, whatever, from where you get this library, you can include them here. And it doesn't matter if it's a integrated library, if it's a simple schematic library, or if it's a database library. They all come together at this drop-down list from where you can select the library you want and then place the components. So we will now move on and create our first schematic library, which we have to integrate in this direction. So click on your project, make a right click on it. You can add it directly to the project, add new to project, and you can see schematic library is available here. But you could also create a new one which is not integrated or not connected to the project, which can be located at a server or something, or a space where in your network, from where you can get access to it. You can click it, you can create it from here, new, and click to library. Schematic libraries also available right here. Okay. Also other types of libraries like the integrated library we talked about before, or database libraries are available right here. In our case, I will add the library to our project. Okay. schematic library. As you can see, another panel opens up. It's the so-called schematic library panel. It's also available via the menu panels over here. You can see all components which are included right here, and defaultly it comes up with one component from where you can directly dive right into it and create your schematic symbol. So we will draw a symbol right now. Our first component will be a ESP32 microcontroller with integrated Wi-Fi. I have the datasheet open right here. And from there you get a description, the so-called pin description, where you see all the existing pins on this device with all its net names, its functionality description right here. And you see if it's what kind of type the defined pin is. It's a power pin, it's an input pin, or I/O or something like that. We will create this symbol for the ESP32 right now. The component has 38 pins. We can create the pins in our schematic library with the menu place. Click on the first entry, it's called pin, and it will start with pin 0. I could easily press your tabulator key, and from there you can edit the first name or the first designator. We will change the designator to 1 because we start counting with 1, and we can type in ground because the first pin is a ground pin, and then we will start from right there. And as you can see, it increments when I place the first pin, it increments the designator. So I will now add all 38 pins. So, and now I have all pins with the correct number. What we now have to edit is the correct name of the pin. For this section, we will scroll a little bit down to the pin description of the datasheet, and we can select easily the 1 pin to, in this case, 7. And after that, another panel is very useful. You could switch to the schematic list, schematic lib list in this case, because we are currently in a library and it's on my other screen. I will move it right here. So pop on the right side, and from there you can easily edit all those names. I will see which pins we have selected right here. It's 1 to 7, and in this menu you could select the change the menu from view to edit. Only selected objects will appear. From the current component, include all type of objects, and I will change this to display only pins. Okay, and when you now filter the entries right here in the epsilon direction and start from the biggest coordinate, so it's the upper pin, we could easily go this list down and have the same listing right here. So ground is my first pin, second pin is 3 V3 volts. Then number 3 is the enable pin. We have sensor VP. IO34 and IO35. So I will move on like this. I will do the complete pinning of this component, and we'll see at the end. I will skip this one for you, okay? So as you can see, we have finished our pinning, the naming of the pins. So first of all, I will do a double checking of this section, because every mistake here is really annoying later in the process. So I will double check the complete pins right now. I go on like this. I select the first pin, I check ground, I check 1, and I go to the complete list. I check ground, I check 1, okay, it's a ground pin. 3v3, 2, 3v3, 2. Enable 3, 3 enable. Sensor VP 4, sensor VP 4, okay. IO22 36, 36 IO22, 23 37, and finally ground on 38. Looks good. The next thing I have to do right now is to check if every pin has its corresponding type. So we have to double check if it's IO, if it's a power pin, and we will do this right now. You can easily select all the pins, and there's another function which is available, I guess. I don't know if it's really existing, but we can double check it. When you make a right click on this on the section right here, you can choose columns, and there's also the designator available. Show designator. We have show name right here. I will move it up a little bit. No, show designator wasn't the right. Choose column. Show designator, show name. Yeah, that's what I want to see. The pin designator I want to see. I will filter it. So I have the correct order, like it's in the datasheet. Okay, sorry. So from there I can easily change the electrical type. Currently it's a passive. First one in my opinion is a power. So I will change it to power. Also the second one, it's also a power pin. The enable is an input. So we'll change it to input. Also sensor VP and IO34 are all inputs. And 35 also. IO32 is a IO. And I guess the most pins are IOs. IO is to IO12. By clicking shift and selecting all those electrical types, you could, I don't know if it's, you can hit the space bar and then change to IO, and it will change all selected to IO. So currently only I have to edit this one to a power pin. IO13 is also IO. So the rest, as you can see, most are IOs. I will change all to IO, and after that, no, that doesn't work. Power pin, change all those, spacebar to IO, hit enter, and it will change all selected to IO. And after that I can easily select the non-connected and click it passive, and also The other one, it was the ground, I guess. The last one, 38, is also power. Oops. And to me it looks good. So we have I/O, 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 power, I/O, 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 and input to power. Okay, that looks pretty good to me. Let's change this schematic list and go back to our schematic symbol. So in the next step, I will arrange the pins. I will group them in a logical order and also draw a schematic symbol, the body of the schematic symbol. You can do it with the menu place and click on place rectangle. Default is a rectangle which is yellow with a red marked edge. You can place it like that, zoom out a little bit, and then arrange the pins like you want in groups. We'll group them, all power grounds together. For example, if you want to flip those pins in X direction or in epsilon direction, just simply drag and drop them and click X on your keyboard, or epsilon for epsilon direction, for something like that. Now what you see is the rectangle is overlapping my pin names, so I have to select this one and set it to the back. You can do it with edit, move, send to back, click on it, and now you can see all the pins and its name. We have also 3v3. I will choose all the inputs, place them right here. Also the not connected pin right here. And now I have to use this pins for the JTAG interface, and all the others I guess are IOs and UART here. Okay, so then I will bring them in an order so it looks better to me. I will make this one a little bit bigger because I need a lot more space for the output. And IO19 here, IO21. Most times I use this drawing style, so I have one part and everything on the left. Most times those are inputs, but in this particular case I have many IOs which I want to be positioned on the right side. I can also place them a little bit closer, something like that. You have nothing forgotten. Okay, looks pretty good to me. It's my first state. I draw them, I make the naming, and after that I make the first positioning, which I have done right now. And during the design process, most times I come back to this orientation and fix it and adjust it a little bit so that it fits to my belongings when I draw a schematic document. Okay, so we will leave it as it is currently, and maybe we will come back to it later and do some adjustments right here. Okay, So click on the Save button to ensure it's saved. You can also open the Schematic library panel, and as you can see, we have only one component existing in our schematic library. It's called component 1, and this is our ESP32, and I will name it correspondingly component ESP32, and the designator, it's a U question mark. The question mark is a placeholder for our further designators. The incrementing of the annotation will take place of the question mark. I will hide the comment. It's a good point in the editing process where you can add a supplier link. We can edit them right here in the properties panel and click on add, and after that you get a search based on the keyword ESP32. You could choose the full name. I have it ESP32 VROM 32D, and then you can decide which type you want. I want to use this one, 16 MBs. 4 suppliers right here, looks pretty good to me. But okay, it will be added to your schematic symbol. It's based on DigiKey and some others. As you can see, we have also the datasheet right here. Right here. And it's the link. We have one supplier, DigiKey. It's about 4.55 US dollars. Supplier part number is right here. I think that's enough information for creating the first symbol. You could also, as you can see, the number here is automatically highlighted, so you can disable it here. You don't see it right there. Or you could easily enable it and place it here. So there's only one minor adjustment which I want to add in this component. As you can see, the schematic library panel on the left shows me the name of this component, the ESP32. When you make a double click on it, you can edit those preferences. So I want to rename the ESP32 with a more detailed name. It's in my memory here. ESP32 VROM 32D. That's the exact type of component which we have drawn here. So don't forget the designator right here. So in the next step, I would like to add a footprint. We will draw our own footprint of this component, and so so we need a land pattern to know how big the footprint is in detail. So we have added the part choice information, and from there it's very simple to get a datasheet. Only click the link here and you get the right datasheet right here. And from there we can scroll a little bit down and take a look over the contents. There's the pin layout right here, which we used before. But there's also a kind of land pattern for the footprint, which we want to use right now. Just scroll down a little bit. There comes a schematic, some more detailed information about the packages, the physical dimensions of all these modules. And here we are. Here's the recommended PCB land pattern. And sometimes there are more available. Yes, there are 2 right now. That's the 32U, and we have the 32D. So let's take a closer look at this land pattern. As you can see, the blue highlighted, blue marked areas are the copper pads, and the red circles are wires, especially thermal wires for the complete pad on the bottom of this component to ensure the heat can get away from this component. As you can see, they have placed the wires in the exposed pad in the middle and in between those pads. But I don't want to place the pads in the footprint. We will place them later during the placement process in the PCB document and when we come to wire placement and routing. Okay, so first of all, we have to take a closer look at those pads. The measurements are 2 millimeters and 0.9 millimeters of each pad, and we have to order them in the same direction like here, and totally there are 38 pads. So let's start it. In the Altium Designer, we have to switch to the projects panel, and we can now add a footprint library to our current project. Make a right click on our demo project and click on add new to project, and there you can choose it's a PCB library. What opens up is an empty library, also with identically like it was in the schematic library, with one component, and from there we can start. Start with place and place pad. The default when you place your first pad in an empty library is a THT pad, a through-hole pad, but we need SMD pads, so pads which are only existing only existing copper on one layer at the top layer. You can place them and edit the pad after placement, but you could also hit the tabulator button on your keyboard. Then you are in a so-called pause mode, and from there you can edit the pad preferences. So the designator is pretty good. We will start with 1, but what you have to choose right now is we have to change the layer from multi-layer to top layer. And when you change the layer, the pad will change from a through-hole pad to a SMD pad. The rest is in the upper section is okay. We have to edit now the shape of the pad. We don't need a round pad, we need a rectangular instead, and we want to have 0.9 millimeters. You could also, when your units are mil, you could also type millimeters, and I think it was 2.0 millimeters. So just double check it with the land pattern. As you can see, 2.0 and 0.9 millimeters is our first pad. So I would choose the orientation of the pads now. I will set our origin in the middle in X dimension, but at the bottom of the package in epsilon direction. And I will show you later how we can add this. And but for now we have to know our orientation, our X and epsilon coordinates for our first pad. So in X, it's the middle right here, so it's minus 8.5 millimeters. And in epsilon, as you can see, we have a spacing, a pitch of 1.27 millimeters. So that's 50 mils in between each pad. So, and those are 14 pads. Sorry, I have 13 times the spacing. And we have to add 1.5 millimeters. So it's 18.01. So, and from there we can do a little trick. We will now place the first pad, place it where you want, and make a right click. Then make a double click on the pad and edit the X and epsilon dimensions. But first of all, I will go to the properties panel and change units. Currently they are mils, but we will switch to millimeters right here. And after that, make a double click again. And now we can edit those X and epsilon coordinates. So in X, it's the minus 8.5. Sorry, 5. And in epsilon, it's 18.01. Oops, where it is? There it is. Okay. So, and now we can do a little trick. We can select one single pad, make a Ctrl+C, and hit the cursor on the middle, snap to the middle of the pad. And after that, we can use a command which is called paste special. You will find it under edit and paste special right here, where you can paste arrays of pads. Click on the paste on current layer must be marked on. Click on paste array. Then use the item count to 14 and text increment 1. It's a linear array type, and we will move on with the spacing in minus 1.27 millimeters, and click OK, and click OK. Click in the middle on the pad. So, and now we can double check the coordinate of this pad here. It must be 1.5. Double check. The middle of this is at 1.5. Okay. So let's do the same for the 15th pad. Just simply copy and paste it. Rotate it. Place it right here. And we will add a 5 right here. And let's see where it must be located. The 15 pad has 1, 2, 3, 4. So this would be the center of our pads. So there are 5 pads on each side. So we have 4 times the pitch, and we have to add a half pitch. And in epsilon, it's 0.5 from the edge. So our middle of the pad must be 0.5 plus. So let's see. Right here, 0.5. I will calculate in mil. So it's 225, I guess, in mil. 50 mil pitch, 4 times pitch and a half one. Yeah, 225. Looks pretty good. So now we can do the same. Just double check if it's okay. Okay, it looks good. Now we can do the same as before. Just copy this one with the shortcuts E, A, paste special, paste in current layer, paste array. We want the linear one. We want the item count of 10. Let's see if it works. And we want 1.27 millimeters right here and nothing in epsilon. I'm excited about it, if it will work, if it will increment the numbers correctly. We will see it. Maybe we have to adjust something right here, but I don't know right now. let's see if it works. It worked. Cool. Thank you, Altium. Okay, and now we will do exactly the same right here. For this case, we have a symmetrical, our pads are symmetrical orientated around our center. So we can now copy this one, Control C, navigate as a reference point to the middle of our center, snap to it, and press Control V. And now you can toggle it, you can mirror this pad by pressing the X button. So it will mirror, mirror across the epsilon axis. So, and just place it right here. It's really easy to double check the coordinates: minus 8.5 millimeters, 1.5 millimeters. So it must be plus 8.5 millimeters, 1.5 millimeters. So, and 24 we are here. So this one must be 25, and copy it, do it again, E, A, paste current layer, paste array. Item count is 14, and this one right here must be here. And place it. Yeah, that's it. We have now all pads of this little footprint. Not all. We have to add some for the exposed pad. So as you can see, we have to add the 9 pads in the middle, those square pads with a measurement of 1.33 millimeters square, 1.33 millimeters each. And it's orientated in epsilon direction. It's 10.51 millimeters, the centered pad of this pad array, and also in X dimensions. It's the measurement here is from the side of the module. It's 8 millimeters, and the middle is in 9 millimeters. So I have to move it 1 millimeter minus X in our belonging to our center or region. Back in our PCB library, we can now simply just copy and paste the existing pad. Make a double click on it and position it minus 1 millimeter and in epsilon 10.51 millimeters. And we have to edit the pad shape. It's 1.33 millimeters, the pad dimensions, I mean, 1.33 millimeters. So let's do the double check with the land pattern. We have 10.51 millimeters and minus 1 right here from our origin, which is located at the bottom center of the footprint. Okay, so after that we have to use the pitch of these pads to place the other pads correctly. But as you see in this datasheet, in this land pattern, the pitch is not dimensioned correctly, so we have to do a little calculation. As we can see, we have 5 millimeters right here, and we have 3 times the pad, so it's 5 millimeters minus, it's 3.99, and we have to divide it by 2 because it's 2 gaps right here. And to get the pitch, now we have the gap, we have to add 1 pad length. So it's plus 1.33 millimeters, and that's our pitch, 1.84 millimeters, 83.5. Okay. So let's go back to the Altium Designer, and will show you a method how you can simply copy and paste this existing pad and place it with Control V at exactly the same position. And After that, keep the first one selected, and you can use a tool. It's underneath the menu, edit, move selection by XY, and we will use 1.80 millimeters, and we have to type a 0 right here, click OK, and after that it's positioned correctly. Now the trick is select the other one, also press Ctrl C and select the center of the other pad. After that you can Ctrl V and rotate the missing pads. Could also go like this, copy all of them and place. So it's a real fast way and exact way to place such an array. Double check it, that's the centered pad. Okay, looks pretty good to me. We make a measurement. You can use the reports, measure distance. Exactly what we calculated. Shift C will clear all measurements. So okay, what we have now to do is, as you can see, the designator of those pads are identically like our first one, and we don't want it that way. I want to use it. Sorry, I want to use the designator 39 instead. So select all of the pads, navigate to the properties panel on the left and type in 39. After that, what we now have to do is we have to add pin 39 in our schematic symbol. But before we do that, I want to make sure that we are connecting the exposed pad to the right net. We will check the datasheet again if we find something. There's a little schematic right here, and as you can see, there's also pin 39 and it's connected to ground, so it's a power ground or pad ground, something like this. This one here is the schematic of the chip with some external components which are necessary for using the chip, and we have also a schematic right here which describes the complete module. There is also a good indicator for pin 39 ground. You can see it right here. So that's enough information for me to be sure that we have to connect those exposed pads to ground. So go back to the Altium Designer, and we will now switch to our schematic symbol where we can add another pin right here. Copy this one, copy and paste it, and make a double click on it, edit the 38 to a 39, and we will call it EP ground for exposed pad. And the electrical type is pretty good, it's power, so everything's fine. Just save it and go back to the PCB library. Okay, what do we now have to do is we have to add some layers. We will switch to the view configuration, and I will share some information with you because you have, maybe you mentioned it before, there are mechanical layers and component layer pairs available, and I want to add some component layer pairs so that we are sure the footprint is really completed. First of all, I will show you my little file right here. I have an Excel document where you can see what kind of layer types I want to use. I want to add those layers here because those layers are very important for the component. There's component layer pairs. As you can see, it's a 3D body, it's a courtyard, and it's the assembly. And we will use those layers as component layer pairs. So if you flip a component from top to bottom or vice versa, you don't have to take care about the assembly drawings, the courtyard and the 3D body if they are also flipped again when you do it like that. Okay, so back in the Altium Designer, I will add component layer pairs here, right here, add component layer pair, and I will call it 3D body. Yeah, double check it, 3D body. And we want to use mechanical 10 and mechanical 11 for that. So 10, it's the top, and 11 is our bottom. And here can you select the layer type. We will just simply use also 3D body. Okay, and do it again at component layer pair. We will call this one assembly. Choose assembly right here. Just go back. Assembly, for assembly we will use 14 and 15. Okay, and the final one, it's our courtyard. Also select courtyard, and I think it was 12 and 13. 12 and 13. Okay, before we edit those several layers with the additional information, I mentioned it early in the tutorial, we have to move the complete component in epsilon direction, because as you see, our origin is right here at the bottom, but it must be at the center of the module. So let's do a double check again in the datasheet, and it's in X dimension, it's currently centered, so we don't have to take care about the X orientation, but the epsilon orientation is at 0 right here, and we want to use it in the middle of this dimension here. So it's 12.75 millimeters in epsilon. All we can do now is select all of the pads and use the move command, move selection by X epsilon, 12.75 millimeters, and we have to make sure that's in minus. And now the origin is setting up correctly. We can now move on with the other layers. As you can see on the left side, we have our additional component layer pairs available. I only use the top layers during the complete creating process of a PCB footprint, so I don't take care about the bottom. And we can now switch to top 3D body layer and add the first 3D body. Just navigate to the place menu and click on 3D body, and I have downloaded a correct version of the ESP32, and I can now place it on the center on our origin. Make a 3D double check, see if it looks good. All the pins are correct. Looks pretty good to me. Okay, go back to 2D layer mode. Shift S, we will switch to the single layer mode, and we go to the top layer, and we will start with the next. I think we can create the assembly drawings, and we have to navigate to this side on the data sheet. That's the wrong one, this one. That's the complete module with the antenna area. So we have dimensions of 18.1 millimeters and 25.6 millimeters in total, and we will use our assembly layer for the maximum outline of our component. So 18.1 and 25.6. Navigate to the top assembly and click on place line. Make a double click on it. It's 0.12 millimeters thickness. That's pretty good. And it's from epsilon minus 12.8 millimeters to 12.8 millimeters. Okay, and now see it's in X, it's minus 9.1 millimeter and also minus 9.1 millimeter. Minus 9.1. So that looks good. Okay. Double check it, minus 9.1 and X, minus 12.8. Okay. We can copy this one, select the center, and just paste it. And after that I will copy another one. And place it like this. Okay. So what else do we have on the assembly? I want to place a string, place string, which is called dot designator. It's a placeholder for a designator. I will use kind of assembly drawing later in during the design process, and so I want to have a printed assembly drawing, and for that case I want to use this layer. So, and I want to add this one here. Just check the details. And something like that. I also use the justification right here. So I'm sure that's completely in the middle, because the placeholder here, it depends on what is written in the designator. So if you have a board with multiple chips, the designator gets a little bit bigger, and so I don't have to care about the orientation if I use this justification right here. So it's always in the middle. Maybe do it like that, and reports, measure distance, something about that. So 5 millimeters plus. Okay, the next thing I want to show the first pin. This one is the first pin, so I want to use this corner right here to show it in the assembly. Something like that. The next thing I want to add is our courtyard, and for that case, because it's a really it's a rectangle module, I will copy and paste this one. Navigate to the courtyard, press E and paste special. Paste on current layer, paste. I don't want a designator right in here in this layer. And we have to move this one back. Okay, that also looks good to me. So we have the courtyard, we have the 3D body, we have the top assembly. What else do we need? We need an overlay. So let's start with an overlay and place a line right here. Maybe something like that. I will double check the distance. Sorry, reports measure distance. That's enough. I want to use all layers in the snap distance, and I can copy this element right here, paste it and flip it. I have to enlarge the courtyard a little bit. Okay, it looks pretty good. What I do have to adjust is the thickness of the line width. I want to 0.13 millimeters. That's enough. And as see, I have a mistake in the courtyard. Just update them. It must be not 0.12 millimeters, 0.01 millimeters. Exactly like that. So it looks pretty good to me. Take a look at the 3D view of it. I will adjust the settings, the view options. Those are a little bit close, but it should be okay. So all we have to do right now is we have to name the footprint correctly. Go to the PCB libraries menu and make a double click on the component, and I will select the name from the datasheet, this one. Do it like that, and rest is okay. Height is interesting. Height is the complete module is 3.2 millimeters. 3.2 millimeters. Okay. And after that, you can save it. And we will now combine the schematic library, the schematic symbol, sorry, with the footprint we created right now. Just go to the library back and click on Add Footprint right here, Footprint, and on the Browse tab, you will get the correct library. The libraries are available right here, and we have only one currently, so this one is our footprint. Now they are linked together and we can save it. And then we open our project again, our schematic sheet. We can now use this component. So place the component, place part, and we will use our schematic library, place ESP. To annotation. Design, update PCB document, execute the changes, and we will see how it looks. Now we have U1 for our designator, also U1 here, and looks pretty good. Our first component with the Altium Designer 21. So I hope you found this video helpful, and I hope you can use a few tips and tricks in your daily work. If you want to see more of that, just write me an email or use the comment function of YouTube. Thanks for watching. See you in the next tutorial. Bye bye.